Hello, good day. Once again, you are welcome back. In this partial class, we're going to be looking at trigonometric ratio of compound angles. Here we look at sine in this very class. In my subsequent class, we shall be looking at that of cosine. Here we'll be making use of this diagram. Uh, let's take a look at the diagram below and see what is obtainable. Here we have different diagram within some few diagram. Here we have a right angle triangle OQP, and the angle is theta. Then we have another right angle triangle ORQ, and the angle is alpha. Here, a perpendicular line is drawn from R to OP, and the meeting point is referred to as N. So here we can see that this angle here, and here we have another triangle, we have another triangle here, okay? So it means this angle here and this, they are alternates. So if this angle is alpha, that means this angle is also alpha, interior opposite angle. So here, if this is alpha and this is a right angle triangle, which is angle 90, that means this angle here is theta as well. Okay, we use this part to continue what we tend to establish. Now, but also take note that the line arrow n is the same thing as arrow s plus sn, but xn is the same thing as qp. Okay, so we'll be making use of these angles here, and these angles and this angle with the diagrams. Now let's look at the angle, the two angle involved. We have the alpha and theta, okay, or theta and alpha. Here, let's consider the case when these two angles, alpha and theta, are acute angle, and that their sum is also acute. You know, acute angle, that those angles that are usually less than 90 degree. Okay, here from this triangle here, we have another triangle. Once from this perpendicular line from arrow to n, we have another triangle which is ORN. So we use that one to establish our fact that sine, the sum of this angle, theta plus alpha, is equal to sine is opposite. The opposite of these two angles is Rn, while the hypotenuse is OR. So the sine theta plus alpha here is Rn over the line OR. Okay, but the line Rn, like I said, the line Rn is Sn plus SR, but Sn is the same thing. Sn here is the same thing as QP. Okay, so we can now rewrite this expression that arrow is the sum of Sn plus sum of Sn and Sr. So here, this can be written as Xn over the line OR plus SR over OR. But recall that Xn is the same thing as the line PQ. So this becomes PQ over OR plus SR over OR. Now we need to establish some fact here that this expression PQ over QR can also be written as PQ over OQ times OQ over OR. Similarly, SR over OR can also be written as XR over QR times QR over OR. Here, these are the facts that are all generated from within these diagrams. Okay, we shall be explaining them bit by bit. Okay, so here, if that is done, let's now look at this from the triangle OPQ. Let's look at the triangle OPQ. P and Q, which is with the angle theta here. Uh, Here, what connects QP and OQ is sine, opposite over hypotenuse. So here we can see that PQ over OQ is sine theta. Okay, and from the triangle ORQ. Now look at this. We're looking at this angle here. This angle here, alpha. ORQ. Okay, here this is alpha. So this is opposite. That means this is the hypotenuse. What connect OQ and ORO is the cosine. So here we can now confidently say that from this triangle here, OQ over ORO is equal to cos alpha. Then from triangle SRQ, let's look at triangle XRQ. Okay, XRQ here. So which is also part of the diagram here. So here we have the angle here theta. This is opposite. Now let's look at what connects SRO and QR. Okay, we are looking at here from triangle SROQ, SRO over QR, because we are looking at this term here, SRO over QRO. And what connected is the cos theta, because cos is adjacent, which is SRO over the hypotenuse ROQ. That's what connected, that's the relationship here. So that means cos theta. Now similarly, now let's look what connects Q arrow over O arrow. Let's look at it. Q arrow over O arrow from alpha here, because we already used theta here, so we're looking for the other alpha within triangle O arrow Q. So what connect this here? This is opposite, and this is what? This is hypotenuse. That means this is sine alpha. So what connects this expression here, Q arrow over O arrow, is sine alpha. Now substituting it in this expression, this becomes sine theta plus alpha is equal to sine theta cos alpha plus cos theta sine alpha. Now imagine if we are going to derive for the difference here, sine theta minus alpha, we replace alpha by minus alpha, and the expression become sine theta cos alpha minus cos theta sine alpha. The reason being that we are dealing with the acute angles, and they all fall within the first quadrant. It simply means that they are all sine. Take care. That means all in the first quadrant, since it is acute angle, they are all positive. So it will affect sine or cos or sine theta or cos alpha or cos theta sine alpha. So, but the only difference here is the sign here will definitely change. This is how to conveniently derive the trigonometry for compound angles. In our next class, we shall be looking at that, of course. If you like this video, please help me subscribe and also share to other social media platforms.